Hey guys, this is Coach Brian bringing you your day 1-1 notes over measuring segments. So just a reminder of what a segment is. A segment is a piece of a line and it has two distinct points at the end. We call those endpoints. And just like everything else, between any 2 points, there's still an infinite amount of points. So even between those 2 points, no matter how close together or how far apart they are, they still have an infinite amount of points between them. So that's a segment. And then just a reminder, these are rays. Okay, rays have an end point. It's where they originate. I know it says the end point, but it's where they start, and they go out in a direction forever. Okay, they go out in a direction forever. So the important things from today were really what's called the segment addition postulate and learning to measure and combine segments. Our essential understanding is that the sum, which means you are adding all sections of a segment, gives you one larger segment. So essentially what I was saying in class is like, if you have a segment and you connected another one at the end, and then you connected another one at the end, and you could do this, indefinitely. You could keep going and going and going. You end up with one larger segment. Okay? So if you take a bunch of parts and put them together, you get a whole, an entire thing. Okay? We also talked about what is a postulate. A postulate, it's a word you'll see a lot, but it just means it's a statement that's assumed to be true. Okay, a statement that's assumed to be true. It's usually what I would call like common knowledge. It means everyone generally accepts it, and it's usually so simple that it can't be disproven anyway. Some examples of postulates are the ruler postulate, which states that every point on a line can be paired with a unique real number. That's called its coordinate. So like if you looked over here, you would see that the x lines up with 3, the y lines up with 7. Everything in between here, if I added a new point and I made it z, it would be 5. If I added a point over here and made it a, it would be 1. So pretty much what it's saying is just that, if it's a number line or ruler, whatever it is, each point on it can be coordinated with a unique number, one-of-a-kind number. We also have this concept of distance on a line. Distance is how far apart two things are. Okay, so if we went over here and we said x is at 3 and y is at 7, you could find their distance if you look right here. You subtract the two numbers, you find their difference, and then you find their absolute value. All right, remember, absolute value is always positive, always positive. So it doesn't matter which order the answers go in or the numbers go in, you're going to get a matching answer. If you don't, you should check. So again, what we just said is that distance is the absolute value of the difference, which means subtraction, of the coordinates, and it's always going to be positive. For today's notes, I just wanted to remind everyone about some of our notation here. So if you have two letters with a line above them and see how there's nothing at the end of the lines, we would call this segment AB. But now we have a lot of different ways that we can, it's not really like a code, but it's almost like a shorthand of geometry. If something is a line, we can call it line AB. If something is a ray, we can call it ray AB. If there's a segment, we can say it's segment AB. And so it's really important to understand what these symbols are above the letters. It's really important to know those. And then sometimes you get the letters with nothing above them. You just get a pair of letters, no symbols. When you see that, we're specifically then referring to the distance from A to B, or whatever two letters there are. But it's the distance between those two letters. We talked in class about the concept of betweenness and distance. Betweenness just means something is in between two other things. I know that seems really basic, but like if I have this segment right here, and this is between them, this is between them, this is between them, this is between them. It's just this concept that if something lies in between 2 points, it's in between them. I know that seems kind of redundant. The distance is how far apart two things are. So obviously you could have two things that are very close together. You could have two things that are much further apart. But all this is to add up to, or to culminate in, the segment addition postulate. That's the big thing of the day. And so what we have is a conditional statement, which we're going to talk about in a future lesson. But a conditional statement is what we call an if-then statement. So what it's saying is like, if this is true, if this, then this. So an example I used in class was like, if I need to get to the 3rd floor to my classroom, I would say, if the stairs are too crowded, then I'll take the elevator. If the elevator is broken, then I'll have to take the stairs. So it's just like, if that first condition is met, then the second thing is going to happen. And so this one says specifically if B is between A and C. And so on our notes, we actually have this picture. See how B is between A and C? So that's true. Then, if that's true, what we've got is we've got two segments, AB, BC. Put them together, you get one bigger segment that we could call AC. So the way we would write that out is we would say, if B is between A and C, then AB plus BC equals AC. Another way that I wrote this out in class was, and it might make it a little easier to remember, but a part plus a part, like we said earlier in this video, a part plus a part equals the whole thing. We worked a couple of examples as a class, so I'll work a few of these with you, but example 1 says B is between A and C, so we can go ahead and draw that. A, B, C, but C is between B and D, so we actually have a 4th point on our line here, D. And then they give us some distances, okay? AB is 24, B to C is 11, C to D is 15. Now if I add all these up, 24 plus 11, that's 35 plus 15. The whole thing, AD, is 50. But that's not what the problem asks. It says find DB. So I'm really just looking for what is this section right here. So 11 plus 15, DB, would be 26. And so that's kind of like the basic straightforward one that gave us all the numbers, gave us all the information we needed. But then I jump down here to the next, and you can see we've got some algebraic expressions in here. So if you can remember still though that a part plus a part equals the whole thing, then you could quickly set up an equation that says 17 plus 3x minus 5 equals 5x plus 2, because that's part 1 right there, part 2 right there, and they equal the whole thing right there. So now what we would do is we would just solve this algebraically. I would combine the 17 and the -5. 17 plus -5 equals 12. I'd bring down my 3x. Can't simplify anything on the right side, so what I would do is I'd subtract 3x from both sides. I'd subtract 2 from both sides. And so what I'd end up with is 10 equals 2x. Divide both sides by 2. X equals 5. Now, that's not what the problem asked me to find. It asked me to find AC. I found X, but I need that X to plug in right there. And when I plug in 5 for X, I get 5 times 5, which is 25, plus 2, which is 27. I skipped 3 in class and I wanted to jump down to congruent. It's a word we'll use a lot in geometry. It means specifically that two objects or items are the same size, but they are also the exact same shape. So a lot of times people will use the word equal, which is totally fine, but congruent has almost like a deeper meaning. It means not only are these objects the exact same dimensions, like they're the exact same in every way. They're the same size, same shape, everything. Midpoint, again, not creative. This is the point in the middle. Okay, it's not like a hidden meaning in there. The point in the middle. It is the point that divides a segment into two congruent, remember that means same size, same shape, two congruent parts or pieces. The rest of these were just some application problems based on what we learned. You should hopefully be able to get those based on what we've done here. The only thing I really want to point out, just to wrap up the notes here, is to again remind you that distance is going to be it's going to be the absolute value of the difference between points. So you could write it like that, or you could write it like this. The order of the numbers shouldn't matter because the absolute value always causes your answer to be positive. And that's really the highlights of 1-1. I'll see you in the next video for 1-2.